We tried to use machine learning as this holistic approach so that we're giving it some features, some information about the similarities between those domains, for example, in the whole internet. And then we're trying to make it use those similarities to sort of automate our tasks.
Hey there, pals. Welcome to the OxyCast, the webcast where we talk about everything web scraping related. My name is Augie, your host, as always. And on the second side of this table, we have Jurijus Gorskovas. Is that right? Yeah. He's a developer at the team called OxyBrains. They're a team that here at Oxylabs we have incredible respect for, mainly because they work with a technology that every developer kind of, sort of knows about, but not completely. We're always curious about it, It's a technology that solves the most mystical problems that we really want to know about, but we just never get to it. Jurijus is an expert in machine learning. Even saying that name out loud sounds a little bit magical to me. So Jurijus, why don't you tell me a little bit about what exactly is machine learning, and how did you get to learn about machine learning in general? And how did you get to be where you are today, a developer in the most magical team here at Oxylabs?
Yeah, hi everyone. Thanks for having me. So if we talk about machine learning, my journey began, in 2015, just from the idea, from what I heard about it. Mainly it was something revolutionary back then with the image classification and maybe object recognition from images. And that really looked magical back then. Why it happened, for example, in 2010s is that we finally reached the expected progress in the hardware. So that's one. And the second thing is that we were able to have and gather a lot of data from the internet. So we have data, we have processing power, and this is where those machine learning algorithms came back to life, because actually they were developed something like in 1860s. So it's been a while since people know about machine learning, and that was something that excited me and sort of directed me to a proper education path, so that I had my final thesis in machine learning and especially in image recognition. I had to do a model which would classify the emotions from the face images of people, and I had like seven different emotions that my model could recognize. And I worked back then. It was just a beta version of TensorFlow, and I've managed to sort of connect it with the Android camera and have an input from there. And I don't know, it was very interesting from both practical and theoretical knowledge, because in theory it's not very clear. As you said, it sounds magical, it looks magical, but it's all math, and it's weird, but it works, let's say.
So 7 emotions, is that right?
Yeah.
What kind of emotions?
It's
Probably
like
anger.
Yeah, anger, happiness, sadness, I don't know, maybe enviness, jealousy, or like some I don't remember, to be honest, all of them.
So that was a long time ago, right?
Yeah.
2010s you mentioned? Any idea what year exactly that was?
When I graduated?
Yeah.
It was 2018.
2018, meaning you've been doing machine learning for 4 years already? Or were you doing something else in the meantime?
Yeah, exactly.
Between now and the time that you completed your thesis.
Yeah, exactly. Back then it was quite a difficult task to find the entry position for a machine learning job. Everyone has been looking for specialists who could introduce some new things to their teams and teach somebody else. So it was really hard to find something for a person which doesn't have experience. And actually that final thesis, it wasn't only required as an academical thing. It was very useful from the practical point of view because after my graduation, when I was going to interviews or looking for machine learning jobs, I could talk about it. I had experience because it takes over half of a year to make as well, to build the model, to document it properly, to write the code and everything else. So it really was helpful when I had to look for the job. But anyway, I didn't manage to find one as an entry position, so I had to sort of travel and find my own path through the experience in other fields. So I worked in France after my graduation as a sort of systems administrator or like monitoring specialist. I used Splunk, sort of a paid version of Elasticsearch, to collect a lot of monitoring, like a lot of logs, basically access logs, security logs.
So just to clarify, is Splunk just like a data storage system?
Not only, it's something like Elasticsearch. It's able to index the data that you're passing to it, and then you use their own language to query that data. And since that data is indexed, it can offer a good, good speed to use.
How did your system administrator job help you with your machine learning knowledge?
Machine learning was always in my head. I was following the trends. I was following the development of all the open source models.
So I'm guessing that even while working as a system administrator, you were still hoping that you would eventually land a machine learning job.
I could choose a different path, for example, to go from the sysadmin to, for example, DevOps. And it would be sort of similar level, let's say, of specialty, just another tree, let's say, of knowledge. But machine learning is fun. That's what separates it from the other things. It's fun when you manage to do something, when you sort of put a lot of effort and time, and you're not sure what are going to be the results, and they actually work. That's an amazing feeling.
I mean, sure, but that's kind of like the passion that I have for software engineering in general. I love to, spend days and days working on something and then finally see it, do something that I was meaning for it to do in the first place.
Yeah, but isn't it like that developer job sort of comes repetitive after some time, or maybe after the short time?
I'd say not really, because you're still solving different problems every single time. I mean, the problems are a little bit related as far as it comes to web development jobs. You're always designing APIs. You're always thinking about how those APIs will interact with databases, but you're reaching for different results, and maybe I'm just the wrong person to ask that, because I did play League of Legends for 5,000 hours in my life, so maybe I'm just used to doing very repetitive tasks and but
I think I spent over 100 days in it too.
Anyways, continuing the topic of machine learning, let's not get too derailed.
Yeah, exactly.
Okay, so Splunk, you did some system administration, and then you decided that you still wanted to go for machine learning jobs, and what then? I sort of tried to not to go too far from that topic, because anyway, if you want to get the job in it, you have to go through the interviews where they pretty much always gonna ask a lot of theory, a lot of recent studies maybe, because it's quite a recently exploded thing. So I had to follow it, and after working in France, when I came back to Lithuania, I found a job in systems operations in NASDAQ. And funny or not, I listened to some machine learning related videos, or some information, or maybe some paper reviews, pretty much every day, as a instead of music or something. Oh, okay. So just
as a part of multitasking.
highly into it, you know, listening to machine learning podcasts every single like second. You're not really doing something that requires your full attention. Yeah, I mean, I can see why you managed to become a machine learning engineer right now.
And you know, it always comes from the idea. And you know, if you build something in your head and you sort of try to go to that direction, once you will have an opportunity, it's more likely that you're going to use it.
The word manifestation comes to mind right now. Okay, so, all right. You got a job at Oxylabs, right? Or was that before even we had like that particular name?
Oh no, it was Oxylabs. It was like a year and a half ago.
Mm-hmm. So why did they decide to pick you? I mean, they probably interviewed you and they understood that you had a big knowledge base from, you know, listening to all of these podcasts. And that's a pitch for every single one of our listeners. You should listen to podcasts, and especially our podcast. But yeah, I guess you just gathered up this huge amount of knowledge throughout the years. You know, you came into the interview, they looked at you and they said, yeah, you're cool, and you got the job.
Well, pretty much, let's say. But a part of the success was actually, as I mentioned, that final thesis, because a project like this requires a lot of like understanding, a lot of reading, paper reading and everything. So the theoretical knowledge was significant. But the practical knowledge, as let's say a common problem for people who look for entry positions or junior positions, is practical knowledge. So I had to prove that I can do something first. So I've gotten a task. I've gotten a task to do for the interview. And you know, to be honest, I was happy where I was. Even when I received the task, the only intention that I had was to check if I can do it. You know, and this is sort of, this sometimes can appear difficult when you work somewhere and you get an opportunity to do something maybe you would like to do, but you're sort of busy on the things that you're currently working on. And sometimes you choose to not to try. And this time I chose to try it. I chose to check basically my knowledge, because I knew that there are people working that actually understand more than me, and that they need, for example, that they need people at the moment. So I could use that opportunity to check my knowledge and to see if I can do it at all. So yeah, I spent a couple days, probably maybe a week, on a task, and I passed the interview too. I had a couple theoretical questions, but mostly it was about that task, you know, because machine learning is like an experimenting. So it's try, fail, try, fail. So the task was more of trying to do it in the best way and then explain why you couldn't do it any better, for example. Mm-hmm. So I don't know. Everyone, like Oxylabs, were happy with the results, and they had a couple ongoing projects in machine learning that sounded pretty interesting to me. So after I passed an interview, I gave it a second thought, and I chose to try to get back to my main path that I was planning before, mm-hmm. to go to machine learning.
So I know that there's a lot of things that you can't talk about when it comes to your job, because you guys are doing top secret kind of stuff. But maybe there is like a nugget of wisdom that you can share, something that you have been working with that's already like possible to talk about with us.
For example, the e-commerce parser?
Yeah, sure. I would love to hear about that part. I'm assuming that as soon as you came here to Oxylabs, that was like the very first project that you worked on. Is that right?
Yeah, like one of a few.
Okay. So what exactly is that? Can you tell me about it? The Universal E-Commerce project?
Yeah, so the point of a team overall was to get the knowledge in machine learning first, then apply that knowledge in everyday, let's say, situations, everyday problems. So once you sort of understand the potential, you start to look for the spots where you can use it to either save the costs or either save time, which is also money. So first we targeted some particular points where, for example, you as a developer spend a lot of time, or maybe not a lot of time, but spend some time reacting to some failures of the parser. Because every domain that you're trying to parse, pretty much, I mean, they're similar in a sense, for example, by the categories, but they're still different by the structure of the web, or you know it better, you know. Mm-hmm. So we tried to use machine learning as this holistic approach, so that we're giving it some features, some information about the similarities between those domains, for example, in the whole internet, and then we're trying to make it use those similarities to sort of automate our tasks. So instead of the developer going to look for the problem and see why particular field or particular information isn't passed, we use first a machine learning algorithm which would, let's say, solve 80% of our problems. And I mean, it would be ideal, I guess. Mm-hmm. And then 20% still remains for the developers, for the manual job, but we reduce it by like 4/5. Mm-hmm. So that was one of the goals, just to apply this as a tool, you know, because it's machine learning, AI. It always, those buzzwords are somewhere there, but
I still feel like we haven't really tackled on what exactly is the Universal E-Commerce project. From my understanding, it's a parser, so it's a piece of software that takes in just HTML content, and it finds a few fields in that content that are like the descriptions, maybe the price, maybe something else. And I'm struggling to understand, like, if I wanted to make something similar at home, how would I, start moving towards that direction?
Yeah, so basically that Universal E-Commerce Parser, it's able to parse the most generic and major fields that you're trying to parse from pages. So in this case, since it's e-commerce related, it's able to parse the main fields of the product items that are most of the time on sale on the internet. So it's like a title of those items, main pictures, description, maybe sizes, or any meta information that you can get. So how to do it is, you need data. You need to basically go through a lot of different e-commerce pages, and see, and actually visualize those similarities that you see. So for example, if the title is in the appropriate position in the web, for example, you can either take a picture and detect where that specific field is, or you can use like XPath to sort of realize the depth of that item. And then once you have a lot of those pages in the data set, let's say, you see statistically, for example, that over 70%, let's say, titles were always on top of the picture, for example. Mm-hmm. So when your model later receives a new web page, a new code, it just first, it looks for it. It looks for the title, and it sees it in the right position, which means most of the time that it's going to be a success. If it doesn't, then it goes for the other features. For example, are there enough of images? Are there like one big image and 3 smaller images, for example? Is the price in bold, for example, or is it in italic, or is it, for example, alt price most of the time is crossed by a red line or something like that. So you sort of collect all those features, and when you kind of stack them up, it gives you that probability, that success probability. And the more data you have, the better. The more features you sort of recognize in that data, the better. If that explains something.
Yeah. How do you describe a feature? So, okay, I still don't quite understand how exactly a machine learning algorithm would find, if we're talking about the title, for example. Let's say that you are trying to describe a feature that tells the machine learning algorithm whether or not there's a text above the image. So how is that like done? Do you think that it would be possible to just out of your like top of the head throw a code example or something? So do you use XPaths or?
Yeah, exactly. I think I mentioned that to recognize the depth of an item within the code, you use XPath. Sometimes we use metadata, JavaScript code as well.
So would it be correct to say that the way you would do something like this is first you find all elements that are header 1 tags? Or
Yeah, that was one of the features, I think, that most, like in sort of 70% or maybe more cases of the data that we had, for example, for the training, we noticed that the title of the item, either header 1 or header 2. So this was one of the features, that if the website contains the headers, there is a chance that it's a product item, for example. It's an e-commerce page.
okay. And then once you have like a feature that does the feature itself basically only tells you whether or not there's like header 1 text inside an HTML piece of content, or like is the result a boolean? Is the result a number? What exactly is the result of that feature function?
Most of the time it's just, I would imagine it as a tree, for example. You build features from the top, and you have a lot of nodes, for example, of the tree. And each, that separation in two is your feature. And first, for example, when you build those features, the model is able to evaluate which feature is more important than the other, which feature brings you more difference to your model and doesn't overfit it, for example. So when you have that list of features, for example, your first feature of the tree will be the most deciding. For example, what in e-commerce page, for example, what appears all the time. So I would say that is title, that is at least one picture of an item, because most of the time we want to see what we're buying, and the price. There's no price, you cannot buy it, you know. So if we look for these three things and we find them, then it's most likely it's a product page that we want to parse. So when you have this tree and your new HTML with your e-commerce page is received, it finds, for example, those three items that we were talking about, and it just decides it goes this way, you know, it's 1, it's not the 0. And then it checks all the remaining features and generates your probability.
Okay.
And once you have like a significant probability from your model on the test data, for example, over 90%, then it's a working model.
Okay, so there's still a few things that I'm struggling to understand. I'm assuming, okay, so if we're trying to create a machine learning model that parses a e-commerce web page, is that just one model? Is that multiple models?
It depends. It depends from the experiments. First, basically, you try to find the most holistic model for your data, because first you have just data, you know, and you try to clean it, you try to build features, and then you have to build an algorithm basically that is going to take that data and learn from it. So you're trying to get to the best point, you're trying to get your data to the best shape, to make it clean, to make it very different from each other, which is also important. That, for example, if you build e-commerce web classifier, let's say, or parser, a universal parser, you try to make as different training data as possible, to make it, for example, from different countries in different languages. You're interested in it to be different, although you want to find the similarities, so that when your model later is going to receive some very different web page, very new web page that it didn't see before, there is a high chance that still it's going to work holistically and parse your needed details, instead of just passing and training it on, let's say, only some big e-commerce sellers, for example, and being able to parse data from those sellers very well, but doing it very badly from the other sources.
So what exactly is a machine learning model? Just can you give me a very simplified version of how the whole process looks like, from an idea that I have that I think that a machine learning algorithm could work for, and a result with something tangible, something that I could try out at home, maybe even.
I see. Yeah. Well, if we think about developing a machine learning model, it's similar to I don't know, building a startup, because you have an idea in the beginning. You sort of understand some particular areas that you have to work on, but you have no idea if it's going to work eventually or not. So it's like a very high uncertainty, but very high expectations as well from it. So when you take that, there are publicly a lot of data to be accessed, and probably on any topic that you want to apply it to.
Okay, what if I give you a particular idea then?
Yeah.
I want to make a machine learning model that would recognize the price in an e-commerce website.
All right, so your data will be the HTML code of each e-commerce page.
That's
so
right.
For example, your goal is to gather a lot of different e-commerce pages and see how similar are they. It sounds weird, but it works from both sides. You have to have a various data for your model, but you have to find similarities in that various data. So, for example, for the price, your signals, your identical things between those HTML codes is what? Is position. For example, the type of text in it. For example, the type of item. For example, you don't need text if you look for the price. You know that you have to have some sort of a number there. Then, if we look for the price, what comes after the price? Currency. In each web page, there is a currency. So you look for the currency item, and most of the time you know that the price is before the currency. Or in UK, let's say case, the pound is before the number. Mm-hmm. So you just look for those two cases, and that's your signals.
Do I need to, if I were to be making such a model, right, would I need to first establish if there's a currency at all? Or would I just basically try to just tell my model, please find me, the currency for this web page? And what happens if there's no currency in the current web page? What are the failure scenarios of such a model, and how would they possibly look like?
I believe that in some countries, they have web pages that don't have, for example, the currency written, because they are focused only on their people. Mm-hmm. So they have just a number, So in these cases, in these maybe not very popular or wide used web pages, it can be challenging to find that. But It's just it's a case of probability, you know. If it's not gonna find a currency sign in your web page that you're giving it, it's gonna look for the other features because it's not the only feature. Okay. It's gonna say that this thing doesn't exist, but are those other things that I'm looking for exist? And if most of them do, it's still gonna generate a good probability that it's a success.
So just to clarify, what exactly is a feature?
Feature is exactly that similarity that you look for when you have an idea. For example, if you have an idea that the price is next to a currency, you have to gather the data, clear the data, and see if it's actually true. So you actually write a text analysis code, let's say, that checks every HTML code that you have and tells you that in this page, currency goes after the price. In this page, currency goes before the price. So you get the statistical probability, and you have to decide from that probability, is your feature good or not? Because if your feature only contains prices where the currency is after the number, then it's going to be very bad on the web pages that you're going to pass it to later where the currency is before. It's just going to say, no, I had 100% training data where the currency was after the price. So if it's before the price, probably it's not good. But you know, this is not the case in our lives. That's why when we have to collect the data, we have to pass it as different data points as possible.
So let's say I have data for both cases.
Yeah.
For when there's for all the three cases.
Is it 50-50%?
Let's say 30-70, right? Just for the sake of
that's
variation. Good. Okay. So, in fact, let's say 30, 70, and 5%. No, 25 and 5%. So the reason I'm saying like these particular numbers is because I'm currently imagining that I have a data set where I have a bunch of pages with a currency sign in the beginning, a bunch of pages that are with the currency sign at the very end, and a few web pages that I have without any currency sign at all because they are specialized for a particular country. So I'm assuming, for what you're telling me right now, that I have to encode two features, right? One feature would be, is there a currency sign at the beginning of a number? And that could give me a good signal that, well, maybe that is actually the price. And another feature would be, is there a currency sign at the beginning of the number? Which would be, you know, another good signal, you know, for a price. And I guess the third one, for when there's no currency sign at all, is it a number? And that would be another feature, I guess.
Well, it depends. If you are sure, 100% sure that the information that you're passing, like the web page that you're passing, are e-commerce indeed, then you can do something like this and pass the pages that don't have currency signs, for example, and just look for the numbers, which makes it quite a difficult task.
Because it could be a phone
but
number
it's gonna
as
be
well, right?
yeah, exactly. That's what I'm trying to get to. So, for example, if you're just gonna look for the currency sign and a number, you're gonna collect. I mean, it's gonna say that pretty much all the pages are valid and product pages or e-commerce pages, which contain those things. So every financial pages, every, I don't know, stock market pages, they all have currencies, they all have numbers. So everything is going to be fine, like for these three particular features. But if you have 35 features, they all sort of merge and generate a single probability, then you can be more sure than just based on these three, you know.
So, features, right? Yeah. Are they booleans? Are they numbers? Are they a function, a single function that returns me some kind of values? What exactly are they, and how do they look in code?
Yeah, well, ideally for the ML model, you want to have a Boolean data point, a Boolean feature. For example, does this right, yes or no? And the best thing to do is to get rid of those which are 50-50. For example, if we give that example we had before with the currency sign, if half of our data points have currency sign before the number and half after, this feature doesn't give us anything. It's just the 50-50 is, it's like if I would just give a random probability, just 50% take this or this. So this feature is bad. And the same thing goes for the feature if it's 99% in the one point and 1% in the other. It means that this feature is very biased to this particular signal that you're checking.
Okay.
So you have to find something like you mentioned, 70-30, 80-20, which gives you a very significant statistical difference between success and the failure, basically.
Okay.
For each feature.
So having a feature that doesn't have a 50% success rate isn't exactly the wrong word for it, but
yeah, it's just it doesn't give any result. If you would somehow be able to print all the, let's say, importance of the features for your model, so that feature that has 50-50 data most of the time, it doesn't give you any difference. If you're gonna take it out, it's just gonna give you the same result.
Right. There was another question that I had in mind. A feature that would only tell me whether or not there are numbers in a web page obviously is not as strong of an indicator as having a currency symbol, right next to a number. So can I manually specify maybe the weight of a feature?
You need all of them. Like you have those holistic features which only say the position, for example, of the price in the web page. Is it visual or is it XPath related according to the depth? It can be both as well. So you look for these holistic features that, for example, I don't know, maybe it's a bad example, but when you give a kid a picture and ask what he sees, he's gonna notice something and miss something else. So you use first this very holistic approach as if you just trying to recognize the scene, of the web page. And this gives you a position, for example, of an item. And the next features that you have, you're checking if it's a number, if that item is a number, if there is a currency next to that item, if there is a title next to the price, let's say, is it far from the price? Are there pictures somewhere next to this data as well? And when these are packed together, they bring a difference. So once you have your features that you assume that are gonna bring you some use later, you have to check them. You have to basically prove that they're useful. So when you have the data and you have the features, you have to check it on some very generic, very, default model, let's say XGBoost. Basically, a model gives you a probability. It gives you a probability if your result if it's a classification, if it's a positive or negative result. If it's some, prediction, let's say, it also gives you a percent of your predicted value, basically, if it's true or not.
Okay.
So when you have your features, you check them against some default model. And when you get the best results possible on that default model, you also are able to fine-tune that model. There is a list of, let's say, hyperparameters that those models or those algorithms consist of, and you can, to some point, you can tweak them a little bit to get a little bit better result on your data, for example. So that's something that you do in the very end when you are sure that the features that remained in your model are bringing you use, are bringing you difference.
So, okay, let's say that I do have a complete model, right? The model checks against the features, to see if it's predicting the right things, right? And that's how, like, at the end of the day, after encoding a bunch of features that are highly likely or highly unlikely to give me an indication whether or not there's a price field in my website.
Yeah.
After I write a bunch of these like features, my model does like a bunch of hits on those particular features. It forms some decisions about the data, and afterwards it can more or less accurately guess which websites contain a price point and which websites don't contain a price point. Is that about right?
Yeah.
Okay, so that was difficult, honestly, extremely so, and I mean, it only makes me respect you more for what you do and like just exactly how much science there is in this whole thing. I think I'm gonna stick to web development. Thank you very much. No, it's interesting. Don't get me wrong. I've been wanting to do like gaming related machine learning projects for as long as I can remember. But you don't exactly need like machine learning for most of the things that you do in life. For example, I've been interested in aimbots for, games like Counter-Strike and that, shooters in general. And you don't need like machine learning to do like those kind of tasks. It's about, getting the player position and finding out where exactly is the head and, finding how to get your mouse from one point to another point. And I think that where I was going with this particular thought is that you don't need machine learning to solve 90% of the problems that you have in your day-to-day life. But what is a problem that you would like to solve that is related to machine learning?
I don't know, you're probably right about this statistic that in most cases it's not needed, but when you have sort of very repetitive problem on a very high scale, it can be very handy, and what would I like to solve in with machine learning? I probably would say something naive like recognizing tumors or cancer, in people's X-rays or something like that.
I don't think that's naive at all. Like the biggest problems that are currently solved in like our lifetime right now are machine learning related. I think that the changes that we're going to have, like from self-driving cars, for example, are going to be huge, and it's just going to change our economy forever. When that problem is.
But don't you feel this tendency that still like people invest in things that are easy to commercialize, not those that are actually useful for the humanity?
I don't think that transportation is just about being commercial or not. I think that transportation was a problem that was, necessary to solve for as long as humans have been around. We've invented the wheel, I don't know how many thousands of years ago, and it wasn't for commercial purposes back then. It was because, humans always had the need to transport things from one place to another. At some level, I think that all problems that are currently being solved are like that. Surely there's a lot of like research in medical fields where like machine learning is applicable. And, surely there's a lot of research going in capitalistic projects. Machine learning is a world-changing technology. It can change the world, but right now it's unfortunately used for commercial things only.
For now, it's on us to change the world.
For now, it's absolutely on us, which is part of the reason why I think it's important to talk about machine learning in general, to teach our audience what exactly machine learning is. How does it work? And how can you use machine learning to solve the problems that you have? Or not just you, maybe think about the bigger picture. What is a problem that you can solve with machine learning that everybody has, but, nobody's motivated enough to solve it at this point yet? It sounds a bit gloomy, but I'd like to think that there's a silver lining here somewhere, that we're teaching, our community to, tackle on these problems, and that we ourselves will do something, to help out with this kind of huge humanitarian problem that we have in life right now. With that being said, I'd like to remind everyone to listen to us on YouTube, on Spotify, on Apple Podcasts, and scrape responsibly and parse safely.